So I wanted to show a couple examples of expected value and just looking at how you can just work it out in the context of a game. So one example is thinking about the lottery. The way the lottery works is by being profitable. They're not losing money, and the way they know how to set the different prizes is by using the idea of expected value. So let's look at an example of a lottery. So let's say that you are selling a certain number of lottery tickets. So we're going to sell 10,000 tickets, and they're $10 each. And then here are the winnings. One ticket, one winner of $5,000. Five win $1,000, and 10 win $200. And that means that all the rest win no money at all. And so this makes a total of 16. So 10,000 minus 16 means 9,984. They win nothing. 9,984. Did I do that right? Yeah, because you add that up, that makes 10,000. Now, the thing that is easy to forget about this problem is that it actually costs you money. So even if you're a winner of $5,000, you paid $10 to get the ticket. And so this actually doesn't become a true plus 5,000 in your bank account. This is a true adding of 49.90. And same idea, $1,000 is actually only a 990 gain. $200 is actually a 190 gain, and most people are going to have a negative 10 impact on their net worth. So the expected value idea that we talked about in the last video is you add up the outcome times the probability that your random variable is that outcome. Okay, so we're going to say what happened and then how likely was that to happen. It's like a weighted average. So if I want to find the expected value of this game, what I'm going to do is, okay, one outcome is that I won $4,990, but that only happens 1 out of 10,000 times. I could also be the $1,000 winner. So $990 improvement in my bank account, 5 out of 10,000 probability of it happening. Same idea with the next one. I could win $190 with a 10 out of 10,000 probability, or I could lose $10 with a 9984 out of 10,000 probability. Okay, you can type all that in to your trusty calculator. So 4990 times 1 over 10,000 plus 990 times 5 over 10,000 plus 190 times 10 over 10,000 minus 10 times 9984 out of 10,000. Now, if I typed everything in correctly, I think I did here, we end up with negative 8.8. And so how can we interpret that number? That means that if you played this game a large number of times, so if you bought a lot of lottery tickets, you would expect to lose $8.8 per ticket that you bought. Again, it's a little counterintuitive because you'll never lose exactly $8.8. That's not one of the possible outcomes, but that is the most likely average outcome. So if you bought 100 tickets, I would expect you to lose close to $880. If you bought 1,000 tickets, I would expect you to lose close to 1,000, so $8,800. And if you bought all of the tickets here, you would lose money. That's the point of the lottery, that the lottery would gain the money. Like, so the other way of thinking about the expected value is from the perspective of the lottery, that on average, they're making that much profit per ticket that they sell on average. Even though they lose a lot of money on the winning tickets, there's so many more of the losing tickets that they're able to make money. So that's how it works with the lottery. Same idea, any game that you go to a casino, anytime you play a game at the casino, the rules are set up so that your expected value is negative. So that even though you might win a jackpot here and there, if there's lots of people playing games lots of times, on average, the casino will make money. On average, the player has a negative expected value and the house has a positive expected value. So I hope that helps out. Again, let me know, comment, ask questions if there's anything else confusing, and I can do more examples if you think that's helpful.